Why is this not highlighted? It's a big, big file. Do, 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 do. Okay, this is ridiculous. My God. Oh. Oh. Oh, okay. There's a lot more tasks than I had anticipated. Mhm. Task 99 is adding this position, and task 100 is adding it again. Now it would be very interesting to know what the child position is of each of those, in order to understand what the hell is going on. Space debug. It's not really working. Hmm. There's the backwards. Utils I2A.h. The fastest integer to ASCII in the universe. So I have to include the header. Okay. And I want to print the child position that belongs to these parents. And how do we do that? So we have a task number. Parents. And these are the tasks. Did what I just did. Print spot task white to move double S. Oh, here's the task. Scrolled over it. Yep, so that is being filled. Here, and this is the current board. And that current board comes from Guess we'll have even more diepe kabels. Yeah, must be able to hold the maximum value. It's going to be a big file, right? Do I even have enough hard disk space here? Oh, yeah, I increased my home directory drastically. I have 79 gigabytes, so that should be enough. Holy fast. How is that even possible? It's 160 megabytes, so nothing. Why is it import them so quickly? No, they're adding it. They're clearly both adding it, yeah. At the same time even. Interesting. Though... Yeah, what's here? So task 100 added it, and task 101 added it. And then if you go up, you see here the word was added. And that's around. So the question is now, where is threadpool 0? Threadpool 0 is in this function, adding it from here. So that is a move. Black to move is the current position, right? That is strange because white did a move. So it like literally spells it out here. Black to move. Oh, yeah, never mind. That is correct. The position is black to move. So in the parent, white is to move. So this is the parent, and then the white moves the king from 1-7 to 2-6, which is allowed. And then we get this position in which black is to move. Yep, okay. Let's see how reproducible these things are. And that was this one. And the other one has a different child position. No, not. Oh, here it is a rook move. 210? No. Wait a minute. Black to move set makes imply parent king, black king 0-1, white king. Oh, it's another. Yeah, it's still a white king move. White king 1-6, and then the king goes to 1-7. The other way around, actually. So we are here, and then we go from 1-7 to 1-6. So that is two different child positions of the same parent. Yeah, I think this is clearly a race condition in the between threads. This can't happen in a single threaded case. I would say that there are only 2 children then, or how do I find that one out? I want to know how many children this parent has. Why is it not printed? Again, this is the parent, and then Y to move. There are a shitload of children, of course, if Y is to move. No, wait, there are... I have to see it in front of me, actually. What is the position? 0-1. So this is the board, then in the corner is here, then the black king is there. And the white king is at 1-7. That's like way far away. And the white rook is at 2-10. 10, well, very high up. This will come mate in 18 position, so yeah. So we have two different threads decoding different positions, namely this position and this position, but those two positions share the same parent. And then one of them probably calls processing child, and the other one as well, and there are a lot of childs, but okay, these two are the last two. And I think that then my... No, I don't get it. I don't get it. There should be only one of them that does the adding parent. How? Why? How can both do that? Let's have a look at the code. This makes no sense. This is the function, right? That's being called. black to move set maximum ply on parents. Black to move set maximum ply on parents. And then we get here, which is not even close to ctags. I don't know. This is where we call it from. And then we get here. And then it prints adding parents from this function, hopefully. So that should still be this function, yep. So both of them get here. Oh, wow. Yeah, there is no atomic involved here at all. What the hell is happening here? This parent didn't have its number of ply determined yet. It must be made in max ply. See above. Okay, yeah, okay, I think I get it. So we have white to move. So the children are found in the order, in increasing order of the number of ply that the position is made. So first we find all the positions with, what did I say? Black to move made in 0 ply because black is already made. And then the parents of that can made in 1 ply, and because the parent white is to move, so white just gives made in 1 ply, and white wants to do that. So if a child position with at that moment the lowest number of ply of all the children of that parent finds a parent that doesn't have it set yet, then that must be the fastest way to give mate. Therefore, as soon as we find any parent that doesn't have number of ply set yet, then we know that going from that parent going to the current child position is the fastest way to give mate. And there might be more of them, but definitely the number of ply in which that parent is made is simply 1 more than the current ply. The ply of the current position, the max ply is just 1 more than the current one. So the current board is the board that the current info, and this object is an info and that belongs to the current board. Therefore, this board is made in info classification ply, aka this. And then we add 1, so if the parent did not have its ply set, then it will choose this move and give mate by going to that position. And then from the parent point of view, where white is to move, the fastest way to give mate is max ply, which is 1 more than the current one. In other words, as soon as we find a parent where this is not set yet, we add it to struggling with my music again. Stupid music, they all have vocals in it. Parent ply equals this add. Okay, so the race condition is simple. Both threads see this, and both threads come here, and both threads call setMate in ply. While what I expected, while coding this for 1 thread, is that one thread will see this, and then sets the number apply, and then the next thread will not see this, because now this was already called. So if this is the case, then only one thread should be calling this. There's only one thread should be seeing this. Yeah, that is annoying. I mean, this race condition, how do I solve it? Parent info is non-const, so there is an a problem here with the fact that this is not thread safe. We're accessing non-const this info object from different threads. Because we have the same parent apparently here. Okay, I really have to see this in my head somehow, but I don't see it. Parent. I want to see the whole tree of parents and children. Okay, we are the children are different. Two different children divided over two different tasks share the same parent. So we have two different tasks that run here get the same parent, which is not a problem because the parent is const. But then I get a non-const reference to the info of that parent. Now we have a problem. At least if I write to it, and of course I'm going to write to it, otherwise I would have made this const. This is just accessor, so I can read it safely. This is just a reading, this is just a reading, no problem there. This is just read, so okay, but now there is a race condition, kind of, unless, well, if we're going to change the value, and we do. Here it is being changed. If there is only one thread that gets here, which is the aim, then also this is safe. I mean, this is specific to this one thread, and then only one of them will do that, so that's all good. I think we're pretty close to thread safe. Yeah, looks very, very close to thread safe. The problem is that if a thread sees this, then that thread must be the only one that calls this. And so it looks like what we need is an exchange and compare. If I could change the set made imply into an exchange and compare, that would work, but then the compare would mean yeah, only set ply if it is still unknown, you know. So if someone else unchanges it, then the compare would fail. Hi Raoul, set made imply. Reading is made equals ply equals also reading. Here we do a write. We do two writes even. First reset the plies, reset the ply bits. The ply becomes 0. And then we set the bits to the bits are first set to 0, otherwise, well, because we do an OR, We do a bitwise OR here because a few bits at the end are used for something else. Therefore, we first have to reset the bits and then we set it. Okay, so what we are going to do here is the following. We have encoded type. I'm going to read a local encoded type. With encoded, so encoded must become an atomic. It's probably also possible with Raoul. I said hello. What language are you speaking? Oh, what language I'm speaking? I'm speaking English. What do you mean? Testing will do. Okay, I'll just continue. So that's probably possible to solve this with the mutex, but I'm deep enough into atomics that I can do this with atomics, I think. So the encoded type is actually just an integer, a built-in type as it were. It's an uint type, it's a custom template, but then, well, in the end it's going to be one of these. So that's a built-in type. So we can just do atomic encoded type. Now we change the type of encoded. So first I have to go over, well, all code, really. So thank God it's private, so we only have to go over the header and the .cxx file. Encoded type is now the underlying type. Encoded itself is atomic, but I don't want to make these things atomic, of course. I mean, like, they're constants here. Constructing constructing atomic is non-atomic, so but you're not allowed to copy an atomic. So you have to you want to make a this is now also an atomic, of course. The member of this classification. Why the volatile is still here, dude? Forget it. I can just delete that. No, but okay, now this thing does not have a copy constructor, so it might be that I just destroyed the copy constructor of classification completely, and I'm not sure if I use it, to be honest. But if that is a problem, then we'll get a compile error, so I'll just forget that for now. Initialize, call this with underlying memory is not already initialized. I'm going to assume that, yeah, that's maybe a bad assumption. I was going to say I'm going to assume that there are no race conditions except the one that I found, which means that this would be single threaded. That makes sense, because if you just set it to 0, I mean, that would be very, very far from a working program. If some other thread at the same time was actually using this already. I mean, nah. I think I'm gonna call initialize and then start all my threads. That's probably how it works. I think that should already be safe. It's an initialization. Yeah, I'm not even going to look into it. I do not like, however, that I just don't like to use sequential consistent atomics when not needed. So if I would write 0 to this with a store with the memory order relaxed, then it feels like I need a guarantee of some kind of synchronization between this and other use of encoded. Which should happen if we do if we wait for any mutex already anyway. So yeah, I feel just a bit uncomfortable with not looking at initialize. Let's just quickly do that. Grep sources initialize. Who is calling initialize? I guess this one. And here maybe, but it's graph initialize. This is the this is classification initializer. That must be this one. That's the only one. Good code. Good code only has a single line where something is being used. The less the better. The whole thing is being set to 0. Okay, so classification set to 0, and the number of children set to 0, and the number of visited children set to 0. The number of visited children is already an atomic, and I'm just assigning 0 to it. Okay, let's not change it. So these two are atomic now, I think. No, just this one. Okay, but I'm already setting this one sequential consistent to 0. Might as well do that for the encoded here as well. So okay, we keep just the equals 0. Reset ply. Well, when is that happening? I mean, we were doing exactly the same thing. Reset ply. That's setting all the masks. No, end. Oh, This is not doing anything. Bit mask. The bits and bit masks are all set, obviously. So mask. Bits mask. Oh, wait a minute. This keeps the bits of bits mask, which is exactly the other bits than ply. So this mask has zeros where the ply thing is stored. So it is correct. A bit lame though. You know, normally you would have also a ply mask and then have a thingy in front of it, a tilde. But I don't have that mask apparently, so. Okay, just have a quick look of that as well. Reset ply, it's probably called from here. And then of course I need to look at where initialize and reset ply is being called from on the info object. Initialize, and that would be here or there. It's called on all info objects in both the black to move and white to move. It's also almost ridiculous to keep looking at this. Reset apply the same thing. So it just applies to every info that we have, possibly billions. Either the reset apply or the initialize, where initialize resets everything to 0 and this just resets the ply bits to 0. And that then is being called on the graph, both of them. And I don't see it, so it is not being called. at the moment. At least initialize is not being called. I think not, I don't see it. No. This one is being called, I'm pretty sure. On graph, yep, here. So the reason is I have a file on disk that has all the ply already set, but I want to, that was calculated using one thread. And now I want to test calculating the ply with multiple threads, which happens below this point. So I reset all the ply to 0, which is necessary for the remaining code to work here. So I can test if the ply is calculated correctly. If I would leave the ply in, then the ply are already set, then I run into all kinds of asserts, because then we try to calculate the number of ply of positions that we already calculated before, and that code doesn't like that. So the only thing that we want is that there is no race condition between this happening and the other threads happening. And there is no race condition because this is the main thread, and the main thread is finishing this before the other threads are even started. The other threads are namely, well, they are already running, but before we add tasks to those threads. Because the main thread does this, and when the main thread is finished with that, then it's gonna do well this code, where eventually it adds tasks. It all happens all the way here. Putting a task in the thread pool queue, which then starts to work with that. But of course, this is not running before the previous thing finished. Now, the funny thing of weekly ordered stuff is that weekly ordered memory or something like that, is that theoretically, if we would do it relaxed here, say, so all the way up here, and I would write 0 with memory order relaxed, then theoretically that could happen whenever, you know. So theoretically, you would say it's possible that then that just wouldn't happen anytime soon, and we would already start these threads. And those threads then would start using that memory location that then still was not reset to 0 by the main thread. But I think that's not possible either, because somewhere in between there must be some kind of barrier, like a mutex. As part of the thread pool queue. Actually, I think already here. It's just a read access type. Queue access, it's a handle pass to get queue. It. Probably queues are queues type. container type, priority queue. This thing should have an add. No, it's hardly interesting anymore. It's I don't know. It's just not happening, right? So let's go to the next things. Reset. Oh. Clear all classification bits. Well, we don't even touch those now. I mean, I read those. We memory map a file that already has them set. So I'm definitely not going to look at that. Same thing here. These are after they're being reset. We call these functions to set them. That is then all synced to disk and stuff, and then later I run my program, which then just uses these values. So they're basically immutable. These bits at least. Encoded it itself isn't, but we don't call this again. I mean, they are already set, those bits. Here we have the real thing that we're going to concentrate on. So it made imply. Okay, so I'm going to skip this one because that's the real thing. These just test it. Now, of course, if we are, this is now an atomic. Then I'm not sure if this is safe. Let's say the bits that we are testing here should not be touched, provided that we treat this thing as an atomic. So every time we write to encode it, we do so atomically because, well, we have to. It's an atomic thing. Therefore, the moment that this is executed, this is going to have consistent ply bits. Classification bits, because we never test those. And then we do an AND with something that only has bits set for the classification bits. So this is then a consistent result. So it doesn't really matter what the other threads are doing to it at the same time, because it is an atomic now. Because those bits don't change, like I just said, we don't call that anymore. So this all should be already thread safe. However, there's not really a reason to read them with memory order sequential consistent here. Because those bits don't change anyway, so I might as well add a load here with standard memory order. Relaxed. But yeah, that is done more based on the fact that those bits never change in my program. So it's a bit fuzzy, a bit hand waving, I must admit. But it's more like, yeah, well, you know, it feels like that this should not matter, and therefore it probably doesn't matter, something like that. Now, apply is a different story, of course, because these bits are actively being changed. Yes, if we would read this while another thread is setting those bits, then we have a problem. In other words, this is not thread safe, this function. Equals, also not thread safe. These two functions may only be called when other synchronization assures that nobody's changing encoded at the same time. Now this is easy to find. This is less easy to find, of course. Just on operator equals. Where is that being used? Comparing two classifications. No clue. So I'll just comment it out. We get compile error. Now we know where it is being used. Then I switch to the .cxx file. And look again for encoded. Write to this writes encoded. I don't think I call that anymore. I should probably remove it. I don't want to write to a different file than my memory mapped file. This explicitly writes to some other file. Let's comment that out as well, because I want to get rid of it sooner or later. Well, write to and read from. Print on. Yeah, this is debug code, so I don't really care. Plus, by the time you print something and it is being changed while you print it, well, whatever. I mean, it's a momentopname. How do you say that in English? The recording of a moment, as it were. It would be maybe tiny little bit nice if it would print something that is consistent. So maybe I should not use encoded here and there, because if it would be changed in the middle, then what I would be printing here would not even refer to the same value then. And on the other hand, this value never changes anyway, like I explained a bit ago, a moment ago. So then the race condition only exists possibly for this value, and I don't really care if it is changed a nanosecond before or after. Yeah, so we can leave this the way it is, I think. It does do a shift, made imply shift here. Do I not already do that here? Yeah, so I could call ply and then add 1 again to just print the actual value, which apparently I want to do here. No, I don't want to do that. Subtract 1 here again. I'm just getting this value in order to be able to compare it with unknown ply, which is bullshit, because the unknown ply refers to what ply returns. This is wrong. But it prints unknown. How the hell does that work? Oh no, unknown, oh, encoded unknown ply. Yeah, okay, that's 0. Yeah, there's probably a better way to do that. Let's just get ply. So I call this, which is an int ply equals well, I want to call ply, so maybe that doesn't work too well. Let's call this ply too. I can call it ply and then put this in front of it, or maybe it will work. Probably doesn't work. I hate this kind of thing. Current ply, there you go. So now this is that -1, which is what I want to print. So here we can put current ply, and I don't need to cast it either anymore. And here I can just compare current ply with unknown ply without the encoded. Unknown ply is an int, is just -1. aka if it was unknown, the encoded was 0, then we subtracted 1 and returned that, so we get -1. If this is -1, then it is unknown. You can delete this. So this is then one place where ply is being called, but I don't really care at this point here, for this function anyway, if ply is being changed at the same moment. Although, it would be nice, of course, if that if there's some kind of synchronization that only makes me print stuff that is not being changed at the same time, but I don't know, would not be a disaster. Now that then leaves just this function here, set made in ply. Apart from the calls to ply. So, okay, now I'm still going to delay that then. Let's see who's calling ply. That is being called a lot. Assert white to move info classification ply equals apply. Okay, I have the following argument. Ply here is not unknown. Ply is slowly increasing. And we demand that the parents here already have it set. And we are only going to set the parents once. So if it is already set, so if the assert does not fire, or should not fire rather, then apparently at this point the value is already immutable, because it should already have been set. And after it is set, it won't be touched again. So it's safe to read it. So what could go wrong is that the assert basically is wrong, but at the moment that we are about to execute it, there's a race condition where some thread sets ply to the correct value. But that should never happen, because yeah, the ply of this thing should not change. Why does it not change? Well, that's a good question. I think it doesn't change because we're completely done with that ply level. We're now working on the next ply. So that synchronization exists. This is completely cool. This is no problem. If it is equal to that ply, then it was safe to read it. And the same thing here. The same thing, but then for black to move. So this positions with this ply should already have been processed, and therefore all positions with this ply already have their ply set and are already immutable. They won't change, so we can just read it. Oh, let's code. What is this? Classification ply equals classification ply and info classification equals what? I think that if this is true, then this is also true. But this was the other race condition, just comparing two classifications. I think this is like old code. I used to have ply separate, so I think this this part wasn't there. It was just info1.ply equals info2.ply, and info classification equals info2 classification. And then later I moved ply into the classification, so then this turned into what it is now. And I didn't delete that, but actually it is the other way around. Since ply is now part of the classification, I might as well just do this. Which is then not compiling, because I removed the equals thing. But I might as well think about if this is thread safe. These are infos of that belong to okay, that's after the fact, yeah. So this graph was completely calculated already, and then I create a new graph which just uses the same memory mapped file. Yeah, because I mean they should be equal. Okay, whatever. There's no race condition here. I think all other threads are already finished, so only the main thread is running here. Next one. Well, that then is also true for every line below this point, right? All the threads are already finished. Oh, there's even commented out. And let's see where the last thread finishes. Somewhere up here. So yeah, we're just completely done here. But there's, I think inside here, yeah. So there's a block, and here's another block. Yeah, this block has an until all task finished. So the main thread waits here until there is no other thread running, and then it does stuff for white to move, and then we do the black to move stuff, which also has a line like that here until all tasks finished. So from this point on, and there's also a break in the part where there's no threads running, and from this point on only the main thread is running. And then we get here, and then we might leave this loop. This is not true anymore. So yeah, definitely here there is only the main thread running. And then of course yeah, okay, the break, but it's the same thing. So we might break here out of it, but that is exactly between starting new threads and having waited for all threads to finish. So the break also happens when there's no threads. It just depends on if black had the last move or white had the last move. So there is no reason to look at anything below that line. This is single thread, single thread, single thread. Then we have a call ply here, info.cxx, the last bunch of calls to ply. Well, this is definitely multi-threaded. Multiple threads call this. However, as a effect, which I'm trying hard to do, and for several days have been fixing bugs to make it so. In the end, if the program works, this should only be called by no matter which thread once per current board. So the current board is unique here. Even though there is many threads calling this function, there will only ever be one thread that uses that exact board. And there is a one-on-one relationship between this board and its info. Dus the current object is also unique because that belongs to that board. The current board is unique, has a unique one-on-one relationship with info. So there's only one thread ever that's going to call this info. This member function on this particular info. Therefore, this is thread safe because there's only one thread ever going to access it. We can safely call ply on it. At that moment, it should be already set as well, which means that it won't change anymore anyway. I don't understand that assert actually. Less than. It is always the case. Apply is returning some value -1. And that value did fit in the apply type. So yeah, this is going to be less than max. I think it's also historically grown. Before I had unknown ply, it was equal to 0. So we needed it to the actual number of ply to be less than the maximum value because we couldn't use 0. And then somehow this line was testing that and now it ended up in this. But ply itself on classification returns encoded type shifted. Oh, that's actually an int type after we shifted. Get integer promotion. This could be a character or 2 bytes. And then after the shift, it's going to be an integer already. But still with the same value. So let's say if it was a byte, then encoded type could never have been more than the maximum value of, I mean, this is an unsigned type, right? So it's one of these types. Now let's say it was this one or this one, so something less than an integer 32 bits. So 8 or 16 bits unsigned, and of course the max value that fits into it there is when it is all one. So it is 255 or 65,536. And then shifted by made imply shift. Yeah, that is less than max, of course. But definitely less than max. I'm completely confused. It is so totally less than max that even the -1 doesn't matter anymore. So encoded stores the number of ply +1. So I have to subtract them -1 again. This test is nonsense. So first of all, it's 100% obvious, and second of all, due to the shift, it's even more obvious than 100% obvious. I would say this should be less than the maximum ply that we can store in the number of bits that we reserved for that. So you have this many bits, and the eventual value then must be the maximum value that we can store is having all these bits set, and ply itself, what we eventually store is one more. So the number of the maximum value that we can store is all these bits set minus 1. That's the number of ply that we can store. And I have this as that mask shifted, made in ply shift. So if you shift this back with that shift, then I get the mask with all one set, and then the number of ply must be less than that. Maybe I should add an it's more like the max encoded ply. So this is now the thing with all the bits set, ply bits being set, and then this must be less than that, because the ply has already one subtracted. This makes more sense. That had nothing to do with thread safety, but okay. Now we get here. Max plies, then the next number of plies, so that we add one back into it, which then should actually also still I guess if this is on the edge, then this might now no longer fit. Is there a possibility that we don't use max ply? Only if they don't have any number of parents, but that seems unlikely. I'm gonna play it safe and demand that this still fits. What function are we in now? I don't know. Let's have to scroll up again. Oh, still in the info black to move. But yeah, like I argued before, this particular info object should be only accessed by one thread at all, which means that any call to classification. Oh, this is on the parent. Okay. Yeah, this is the thread unsafe problem. This again, same argument. Info will only be called, only one thread will use this info member function, or this member function for this particular info. So classification is unique, so we can call ply on that. And then, yeah, I might as well add here also a test. It's kind of missing. Also min-ply must fit. It's not gonna fire, but hey, might as well test it. I did the think work already. It would be a waste not to add it. That looks a thread unsafe as well then. So we compare the ply on a parent again. It's just debug output. It's gonna happen again here though. Fatal error detected, crash. Okay, eventually we get here, which might be thread safe. So the want is that only one thread is gonna do this. Or, yeah, this actually. And I think that all the children that are running at the same time have the same min-ply. So it doesn't really matter here which doesn't matter which thread, meaning which child position does this, because they work all on the same parent and they all have the same min-ply, as long as it's only one of them. And this is atomic. Increment process children. That has been changed to a fetch add. So there is only one thread that's going to do this part. But this is not thread safe. Because now it's possible that there is a thread that yeah, very far-fetched, but it's of course possible. So some thread could read this value. And then another thread, just read this, not execute assert. Then another thread comes here, also reads the same value, which is unknown ply. And then, no, it's not entirely true. Wait a minute, it must be thread unsafe. How? The problem is, of course, that this assert should never fire in the first place. So we are talking about the case now where I think the program is wrong to begin with. So let's say we do call this function twice for the same info. Then it's already not thread safe. That should never happen, and I'm not taking that into account in terms of thread safeness. Or is this also nonsense? Parent info increment positive. I think the problem is that. Good night, Shit and Misha. I think I need a reordering between these two. So like a thread should do this already before it does that, which is allowed if this access is relaxed. Nah, doesn't feel allowed actually. It's the same memory location. So this is a read modify write operation, which is always totally ordered, which means that, well, that means that every thread sees the changes in the same order. So the increment, you increment it, and no thread will see no thread will see 1, 2, 5, 4, 3. I mean, they all see it incremented in the same order, right? And this is the same memory location, and so it's impossible that a given thread would increment already before it reaches this value here, not on the same memory location. So that means that all these plies are being read before this thread executes this, which means that the last child did not call this function yet, which means that this has not and will not be called while we call ply by this thread at this point in this function above this line. Meaning that if the assert does not fail, it is unknown ply, and it will be always unknown ply. So I think we're totally safe here. Yeah, when the assert does fail, then something is wrong to begin with, and then I probably have a race condition maybe, but yeah, hopefully you are just going to assert in most of the cases, if not always, and I know something is wrong. In other words, this seems actually not thread unsafe. I think it's safe. There's only one thread that's going to execute this, and the calls above this won't suffer from the fact that the last thread is going to change it. Because that will be this thread. The very thread that calls all these splice will be the one that is the last one, or not, and then it's also okay. I mean, then it can only be one thread, the last thread. And while we are still here, then we are the last thread, or we are not. But then the last thread was not there yet, and the last thread will not do this unless we are the last thread. I mean, unless we stop here. No, it's just we have to pass this point. Only when this thread is not the last thread, so this is false. Then we have to execute this, and therefore we will already be here before another thread will be the last thread and do this. So at that point we already have read and processed all those plies. I think I finally have them all, because now we go back to the top again. So here's a fix me that is not thread safe, and in the header I had one function that was not thread safe. Did not mark it though. Command process children. Yeah, that is thread safe. Oops, I should have read that probably. I think it said something like this file has been changed. What do you want to do? Oh no. Undo, redo, yeah. If I save this now, then I override the changes that I made in the second ago. Oh yeah, this is what I was working at. Okay, now I have a problem. I wrote it to this file. Ugh, stupid. These changes. I did remove this though. I did remove it. I did remove it here. Okay. No. I think only this function here needs change. Maybe we can just undo all changes. Undo. I commented out stuff. Is legal? Oh no, that's too much. Okay, let's just write it. The file's been changed. Do we really want to write it? Yes. Press enter. And this is the .cxx file. That wasn't changed. This is removed again. I have to add that below made imply mask in the header. Okay, so yeah, theoretically that should be an acquire, but I don't know why. I mean, what am I synchronizing with? The other thing that we do, which is pushing back to the vector, but that vector is single threaded. So not really necessary then. I don't see the need to use an acquire here, but does it hurt? Surely I need some kind of synchronization here with something else than just encoded. What am I looking at then? Parent boards? Child boards? I think nothing. So this function is called from a member function on an info where the info object is a unique per thread. The current position that is being passed as the first argument to the member function is unique per thread. And we just generate all the parents again from that board locally. So those are unique. It's also single threaded. I think there's no synchronization needed at all. I'm gonna use relaxed because I refuse to do acquire. I mean, in my eyes it feels like, why would I do acquire? And that's not. I mean, if you do that and it's not necessary, don't you look stupid? Okay, so we just load that. We made a copy now. And then I'm going to work on the copy. So the copy now has this bits resets and then reset it. So now we have the new value. And now we want to store this new value again in encoded. Well, of course, only if it didn't change yet in the meantime. So now we do an standard it's called compare exchange, and I think we can use strong here because if it fails, then some other thread already updated, call this function updated the number of ply. And then we don't have to do anything, we're just done. It's not like we need to try again or something, just give up. So we don't have a loop. If we don't have a loop, then we can use strong. And I don't know if it's really called like this. Plus I need to look up the... Hello, I clicked on it. Okay, so we have a reference to expected. Expected is, well, it didn't change. And, oh, wait a minute, I need the old value then. This is on the atomic itself. To recall, it's not standard compare. On the atomic, call this. Might as well do everything in one. Take encoded, reset the bits, and then add. Add those. So if encoded is still equal to encoded, aka it was not changed, then put new encoded into it. And everything can be relaxed all the time. And that then is going to return true if the reference object was successfully changed. So let's just do a return because we don't need a loop. What is it called? No discard or something? I want to be sure that we are using it. So this should never fail then, because it's considered to be thread safe already. Because of that. In other words, I want to discard it, but I can't do this because it's a no discard thing. Maybe on, oh, that's horrible. Maybe unused Boolean success, assert success. So for assert is empty because we're having no debug code, then it is unused. But this thing thinks that you cannot, well, we're using it because it's not no discard thing. Okay, and then this is the last piece of code. Okay. So this is not changing. These bits are not changing, rather. Then we can just read that, but these bits are changed by this call. How am I going to do that? Well, this is an atomic load here. So we just make a copy of it at random, and then at that point it turns out to be still unknown. And then it was unknown. Maybe it's not unknown anymore. And then we call set made imply, and then that's going to return success. And then we do this. That it might return success because in the meantime it's not unknown anymore. So what I really want to do is have set made imply only succeed when it is unknown. Still unknown, as it were. How many places am I calling this? Set. Well, this all positions that are made and definitely should be still unknown, right? I mean, it's unknown, and I set it to 0. I have the same problem here actually, so maybe unused. Boolean success, that, and of course that must always be successful. And there's a definition, a comment. This is what we just looked at. It's being called here. There's another command, and here it is called again. These two. Already looked at this one, obviously, so that is okay. Yeah, so that's. Well, is this also called while it is unknown? Well, it should be. I only want to set it once. Come on, it just has to always be unknown. That's because of this. Okay. So this should already be the case, but that it will be unknown. This is still holding because this is the last child, and therefore it was never called yet. This is just the only time we call it on that parent info. So now this is racy. Might as well call this directly. Because if this fails, then well, then it was not unknown anymore. I'm gonna change it so it fails if it is not unknown. Just the same nonsense. Calling this with maxply, and then the assert here is for maxply, so I don't need to assert then in that call really. Yes, minply also had to have that assert. I'm just gonna remove the assert here. Let's swap them again. Okay, it's not no discard. What is it then? Maybe without underscore. No matching member function for call to compare exchange strong. Is my encoded unknown fly const? Oh yeah, no, it's const. I made it const. Why did I make it const? Because if it is no longer, if this is no longer unknown, then it so the compare fails. Then the new value is read into this one, so it cannot be const. Call to implicitly deleted copy constructor. Yeah. They said so. We expected this. So I have to add an copy constructor for classification. Why? I mean, it would be nice to know where it is being used. Well, here. Why do I need a copy constructor info then? That would be interesting to know. And I deleted write to, which is apparently still being used from here. Oh, well, and delete that. Graph write to and graph read from. Yeah, well, let's try deleting the copy constructor of info then, although probably is needed. But we need to know why. Here it is needed. Making a parent info copy. Looks very debuggy-ish. Very debuggy. That is all, and we don't really need it, of course. Let's comment that out for now. I deleted that as well, yes. Because this would be not thread safe anymore. Oh, this is below that point, right? Yeah, so this is single threaded. And again, also single threaded. Okay, so you can keep this because it is not single threaded. Now what? Call to implicitly deleted copy constructor. Now here, what? Oh, because the thing takes it. Thing doesn't take const references. Well, I guess we got rid of the copy constructor then, completely. And why not? Because my infos are memory mapped and I see no reason to make a copy of that ever. For.h. Get rid of the copy constructor. Which means that also classification does not need or have a copy constructor anymore. Oh yeah, I never deleted it. It's just gone now because of this atomic. Or not. Let's clean up these things. They can pretty much be deleted permanently. Oh, this, yeah. Actually, that was because I suspected a race condition. So it's no longer necessary, right? I mean, I made a copy of it and then print that in, but including other stuff. Print that. The apply is already set to. Pump apply is. Just not ever going to happen anymore because I fixed it. Or do we still have a race condition now at this point? No, I don't think so. I'm gonna delete it all. I think it's not necessary. I still print it here as well. And we assert on it. Well, I'm gonna delete this. I don't expect it to happen. So let's first assert. If the assert happens, then I'll add it back. What's with all these if zeros? A lot of commented out stuff. Okay, that can stay. What are they doing? Right to, yeah, permanently deleted the right to, and a load from. Read from. And this is printing stuff. Print more stuff. What the hell is this? Playing moves, I think. Or not. Must be very old code by now. Yeah. Something with playing moves. No, I'm just curious. This is example code, I think. What's it? So is it a test suite? That is never defined. Get succeeding boards. What the hell is that? It's a version 0 stuff or something. No, not called. The big cleanup. No. What did we get this shit? guess. Okay, we got lost in the SPDK stuff. I guess this is where it was working. Yeah, that's where it was. Quick core dump. Holy what? Can't be any faster than this. Apparently I'm calling set made imply now for on a position that is made with ply is unequal 0, or I'm calling it for a position that doesn't have is made set. Which is it? Let's run this in the debugger. Ply 0. So is made is not set on for this position. Shocking. And who is right? Success. Like to move. Info. That is current board. No way that this broke suddenly, right? Let's just uncomment this so I can see what the board it is. That looks totally made to me. So is made is not set suddenly. Why? How is that possible? I didn't even come near that stuff. I don't have the MD5 of that. I just have it from the 32 by 32 board. Probably unlikely that the .back file changed, I would say. Copy the .back to this file, which is then being used, and then the is made is wrong. Suddenly. That is impossible. Why would that happen? I don't get it. Maybe let's regenerate it. Because, I don't know, maybe layout changed or something like that. MD5 sim is this. It's keep that as well. Yeah, the format changed apparently. No, it does run. Yeah, Omar, yeah, sorry. I did not react to your remark. I don't know what you are referring to, which part. That was the atomics stuff. Well, that's hard shit. Are we going to wait for this? This is going to print so much that if I open it later in a file, then it takes half a minute to open it in the editor. Let's not wait for it. Okay, so the correct value now is this. I wish I could understand why it changed though. Did the size change maybe? That seems also extremely unlikely. Nope, size stayed the same. So what the hell did change then? What the hell did change? It's not useful. Oh, that's all zeros. Well, that's a little bit too many zeros. How did that happen? That's also zeros. Never mind. But I already reset it. Oh god, I didn't make a backup. I have to do it, regenerate it again. Your file exists. Oh, but the file did not exist. What? Do we? Huh? Oh no, but they were already 0. I didn't let it finish. I didn't let it finish. You have to delete it, rerun it, and now let it finish. This is not being done. So all zeros were because I didn't let it finish. Okay, and then after I've let it finish, you should be able to get this, and even this should run. Be successful, I mean. And the rest is commented out. Okay, so yeah, let's just remove this file again. And then can I run this in debug mode? Probably. I'm gonna stop anyway, I think. It's 2 a.m. So I'll just start it and then go to bed. Although I think it will only take a few minutes. And I'm curious. Arg. There's just so much debug output. Let's hope that it works and then just quickly run this with optimization, so it is fast. I don't think this will print a lot. It is still printing debug output. What the? What? Make and configure beta test, and then we'll debug on. Cached. Why is it on? I'm so confused. Why would that not have worked? Is this not my builder? Scary shit. Oh, already in it. Still cached. This makes no sense. This is the build directory. Very sure I just deleted that. It is not cached, it's just on. Oh, that's right. Yeah, okay, never mind. Normally I have debug output on. It's just optimized, so debug output is still on. But now we have so much debug output that I don't want it on. Sorry. No, it's off. It's hardly cached then. It was a command line thing. Okay, make. Stops compiling. No template named atomic namespace std. Interesting. The guy is paying for this CP reference protocol, not even asking for donations. Must cost thousands per month. Interesting. Like the whole world is using it by now. Format. F-stream. Blah blah. The whole thing is debug. Running task. Where's that one value that I recognized? Or was it a larger board? Yeah, there was one with 50 here. Okay, so on 140. Yeah, nothing is printed. Oh, CD source. Version 2, thing. No, multiply. 16 by 16. 140. So it seems to have done the correct thing with 2 threads. To know this no longer should be zeros, I hope. It's still all zeros. What the hell? What? Am I completely crazy? That doesn't look good at all. Way too many zeros here. I don't get it. I don't get it. It looks like it works. Just to throw more threads at it in. Let me think. Let me think. It's a different one again. Now we get this. Why? Okay, so if I remove it, I think I should not. Damn it, damn it, damn it. Yeah, I give up. Tell me, how do you solve my problem? I mean, it seems to work, but I just feel like there are too many zeros in my file, so I'm confused. And I think, well, we can do 2 things. I can just generate it from scratch, and then I generate it again, but then after clearing all the apply to 0. At the very least, I should see difference there. So I think I should go to version 2, and then we have to edit this file, and then main. If file does not exist, we run classify. This code is all single threaded. It should totally work, man. Totally should work. like this. So this is not being done. And then we run over all positions that are already made. Let's fill that in, generate apply here. And then we get here. Let's not do this then. Let's just stop here. Turn 0. After this, I mean, if I do return 0 here, is my memory met file automatically being flushed? Uh-oh. Yeah, I would destruct my graph. We destruct the graph, right? So the graph contains the memory map pool. So I destruct the memory map pool, which has a destructor which does the following thing. On map, this should be called. Yeah, okay, so that definitely would write everything to disk. So I'm going to delete this. Just 2, and then we run it again. This should generate it. And now we are back at the previous value. This is not, wow, every time is different, man. Okay, anyway, this is the MD5 that I got when generating it from scratch. Going to delete this one. This probably not good. How does one delete a file in? Delete message, delete. Okay, so I think this is the correct value. How does that thing look like with the hex dump in the beginning? That is the same thing, 16, 16, 4, 4, and it's still all zeros. I really don't get this. Why is the first 1024 things all zeros? But okay, never mind. Let's now assume that this is correct value. So I'm gonna make a backup of it. And then I'm going to run the thing again. And then we create G, and I want to test all this, testing contents for black to move, blah, 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 blah. But the assertion, now I need debug output. I think. The amount of debug output is way too much. That is still a problem. Assert is still here. Yep. So do with optimization, but then with debug output. Source configure make and then run this file, run this program, writing it to a file. Oh, it was pretty. Now it coordinates. Really? And immediately. Okay, this was the problem that I was looking for. Yeah. This makes no sense whatsoever. This makes no sense whatsoever. I'm going to bed. It's getting too late. I'll have to fix this tomorrow. I don't know what I changed. I made this fail. I mean, this does not happen the first time, I think. I mean, if I generate it while the file does not exist. It says using existing. And now this happens from set made imply. So I definitely have to copy my backup back. Yeah, what's the problem here? Oh, this is with optimization, so I can't debug it. Paranoia. It almost looks like, no, that is not true. The is made is false, so the classification is gone. Yeah, well, it gets too late. I go to bed.